day, grade 12 learners. Welcome to today's geography lesson. My name is Rina van Heerden and my co-presenter for this afternoon is Ms. Cynthia Zondi. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Centre. Boys and girls, today we are having a revision lesson for the paper that you write tomorrow, which is your paper 1. At the end of this lesson, you will know how to prepare yourself for the grade 12 National Senior Certificate Examination Paper 1 of 2025. We're going to show you the layout of the paper, examples of questions that can be asked on all the topics, some study tips, and exam writing techniques. Boys and girls, I just want to emphasize the fact that myself and Mrs. Zondi don't know what is in the paper tomorrow. It will be, as it's going to be a surprise for you, it will be a surprise for us as well. We just take some topics and we see if we can revise it again. Boys and girls, you are writing tomorrow morning, Wednesday, the 12th of November, you are writing paper 1. It's not a provincial paper, it's a national paper. So everybody in the country is writing the same paper. Remember, 2 papers to be written, and tomorrow is paper 1 of the 2. You are going to write for 3 hours. You are going to start tomorrow morning, 9 o'clock, and you write until 12 o'clock. The total of the paper for tomorrow is 150 marks. Please be seated in the exam room by 8 o'clock tomorrow morning. Then, section A of your paper consists of question 1, which is climate and weather. We might receive a 1.1 and 1.2. The 1 will be 7 marks, the other one 8, or the 1 8 and the 1 will be 7 marks. But this 2 will give you a total of 15 marks. Question 1.3 is your source-based question out of 15 marks. 1.4, another source-based of 15 marks. And 1.5 is the other source-based on climate and weather, which gives you a total of 60 marks for question 1. Still in section B, we will have question 2 that will cover geomorphology. Again, 2.1 and 2.2 will be short objective questions. If 2.1 is 7, 2.2 will be 8, or the other way around. Then 2.3 will be a source-based question for 15 marks. 2.4 will be another source-based question for 15 marks. And 2.5 will be the last source-based question out of 15 marks. And you will see that the entire question 2 is also 60 marks. Question 2 is also 60 marks. Then section B consists of question 3, which is the map work. You can expect 10 marks. 3.1 will be 10 marks on techniques and calculations. 3.2 will be 12 marks on map interpretation. And 3.3 will be 8 marks on GIS, which means question 3 will be out of 30. And then the grand total, the section A plus section B, is where the 150 marks will come from. We are going to go, I will do the climate and weather this afternoon, and then I will give over to Ms. Cynthia Zondi for the geomorphology. And we are trying to cover most of the topics by means of questions from past papers. With the mid-latitude cyclone, we refer to the infographic below on mid-latitude cyclones. Question 1 is the mid-latitude cyclone mentioned in the extract. You will see here, this is the extract. And there they mention mid-latitude cyclone is in which stage of development. 3.2, give a reason for your answer to question 131. Why did the rainfall mentioned in the extract spread from Cape Town to Mossel Bay and Knysna? There's Cape Town, there's Mossel Bay and Knysna, and then 1.3.4 refer to the graph and determine the lowest and the highest rainfall in millimeters recorded in the Western Cape over 36 hours. 135 with reference to the cross section. This is the cross section. Explain how a well-developed cold front results in heavy rainfall over the Western Cape. So, it's ideal is for you to stop the video on your, if you look at it on your own time and try to answer these questions. Then you will have an idea, do you know your work? So, this 136, how will the heavy rainfall negatively affect the physical environment in and around the Western Cape? You will see that this is 15 marks. It's a source-based question. Let's look at the answers. The mid-latitude cyclone mentioned in the extract is in the which stage? The mature stage. Give a reason for your answer to question 1.3.1. It's a well-developed cold front. There I can see a well-developed cold front. Widespread rainfall to the Western Cape affects the Southwestern Cape. You can see this is the affected area it shows. Here you can see the rainfall, or a well-developed cold sector and a warm sector. There it is, a well-developed cold and a warm sector. And then the presence of this cumulonimbus clouds, which is the head of the cold front, or you can mention the steep gradient. You can see here the marker location is 1 times 2. So any one of these answers can be given as an answer for this specific question. Then, why did the rainfall mentioned in the extract spread from Cape Town to Mossel Bay and Knysna? Because we know a mid-latitude cyclone moves from west to east. There it is, from west to east. And it's driven by the westerly wind belt. Why does it move from west to east? Because it's driven by the westerly winds. Question 1.3.4, refer to the graph and determine the lowest and highest rainfall in millimeters recorded in the Western Cape. You literally have to go and check how much, what was the lowest, what was the highest. The answers is there. Lowest is 15 for 1 mark, 15 millimeter, and the highest is 40 millimeters. There's 2 marks for you. Easy. Then 1.3.5 with reference to the cross section. Now we go back to the cross section. Explain how a well-developed cold front results in heavy rainfall over the Western Cape. The cold front or the cold air undercuts the warm moisture air, that it results in a rapid uplift of warm moisture air. Rising air cools, it condenses, it forms clouds, the cumulonimbus clouds is forming, and then immediately after that, I just want to go back. So there's always a small, for you to remember, air rises, it cools down, it condenses, it forms clouds, and it's raining. I want you to always have this, these occurrences taking place. It first rises, it cools down, it condenses, it forms clouds, and it brings rain. If you remember that, wherever you have to report on the formation of rainfall or precipitation, have that, I want to say, a rhyme or a story or a sentence for you to remember. Okay, then we come to 1.3.6. How will the heavy rainfall negatively affect the physical environment in and around the Western Cape? Remember, it's heavy rain, strong winds. It will result in soil erosions, lots of rain, lots of water. The biodiversity will be destroyed, small animals, houses will be destroyed, destruction of the natural habitat. You can see there they want at least 2. Destruction of natural vegetation, loss of wildlife, wild animals that can die, destruction of the food chain, the ecosystems and the food webs. And then also, more answers, it will cause mass movement, landslides, fertilizers washed into the rivers, which can cause eutrophication. It will obviously result in water pollution. We will have leaching of soil nutrients, it wash away. Low-lying areas will be flooded, and we will have waterlogged conditions, saturation of soil with water. So your options are a lot for those 4 marks. Then, name the wind belt that causes the early easterly movement of the mid-latitude cyclone. Sorry, it's a new question on mid-latitude cyclones. Refer to the plan view. There's your plan view. Identify front A. Which one of the fronts, A or B, is moving faster? Give a reason for your answer to question 1.3.3. Then there is more questions, it's new questions. Give evidence from the sketch that the mid-latitude cyclone is found in the southern hemisphere. Refer to the cold front occlusion, C, and the cross sections. Which one of the cross sections, Y or Z, represents the cold front occlusion at C? Give evidence that C is a cold front occlusion. Explain how the cold front occlusion develops. Okay, let's look at the answers. Question 1, name the wind belt that causes the easterly movement of the mid-latitude cyclone. As we said, it's the westerlies. There's so many ways that I can ask the same content. Refer to the plan view. There's our plan view. Questions will be on that. Identify front A. There's front A. By now, I hope you know it is the cold, it's a cold front. Then, which one of the fronts, A or B, is moving faster? A, the cold front is always moving faster. Give a reason for your answer. The wind speed behind the cold front is faster. You can see here it's actually 1, 2, 3, it's 30 knots. The wind speed behind the warm front is slower. You can see there it's only 10 knots. The answers are there. Ahead of the cold front, the air is warmer or less dense or lighter. Yeah, the air is warmer the air ahead of the cold front is warmer or less dense. Then we go. Which one of the fronts, A or B, is moving faster? Sorry, that's the one we did just now. Give a reason for your answer. Ahead of the front, it's more options. Ahead of the warm front, the air is colder, denser, and heavier. It's there, in that area. Warm front uses the energy to move forward and rise, so he lost some energy. And the pressure gradient associated with the cold front is steeper. We know that steeper the pressure gradient, the stronger the winds, and these winds will push your cold front to move faster. Okay, then give evidence from the sketch that the mid-latitude cyclone is in the southern hemisphere. The clockwise rotation of air, if you look here at your wind direction, you will see it goes clockwise. The position of the low pressure is south of the system. This is the low pressure, is on south of the mid-latitude cyclone. The warm sector and the cold front is north. The warm sector and the cold front is north. There it is, that is north. The cold sector or the warm front is to the south. It's this part. We have backing of the wind occurs, and the apex is to the south, the middle point of the low pressure system. Okay, then refer to the cold front occlusion, C, and the cross sections. Which one of the cross sections, Y or Z, represents the cold front occlusion? You'll see it is a cold front occlusion because the last symbol there is a cold front. So which one of the two? You always check the one that touches the surface, like this one, is the cold front occlusion. That one is the warm front occlusion. This is the cold front occlusion. You look at the one that touches the surface, so it's number Z. It's still the same question. Give evidence that C is a cold front occlusion. The air behind the cold front is colder. It's 10 degrees. It can be even 10 degrees. Than the cool air in front of the warm air. So here I have cold air. You can see that it's 10 degrees. Here it is cool air. You can see it's at 14 degrees. The air behind the cold front is colder than the cool air in front of the warm front. The cold front symbol is the apex of the mid-latitude cyclone. I talk about that one there. And then the cold front touches the surface like we said over there. The cold front has uplifted the warm front, and you can see here the cold front has cut off the warm front from the surface. And then we have this cumulonimbus clouds that is evident. So you can see there only one answer for 2 marks. Refer to the cold. It's another question. Explain the cold front occlusion's development. The cold front, which is moving faster, undercuts the warm front. They want to have you to have those words there. The warm air is forced to rise, resulting in, you see here, the warm sector is getting narrower. The cool air in front of the warm front is completely uplifted. It's completely uplifted. Okay, boys and girls, that was a short revision on mid-latitude cyclones. We're going over to tropical cyclones now. And this is an example of a short objective question on tropical cyclones. And you have to choose between Y and Z in column B. Wind one that steers the tropical cyclone is known as that's very westerlies, is driven the mid-latitude cyclone, so easterlies are driving the tropical cyclone. 2 is known as the I. Very easy if you know your work. Circulation of air around 2 is clockwise. You can see here, sometimes I give you the arrows, but it's a low pressure. And in the southern hemisphere, we know the low pressure is going anti-clockwise. The air pressure at 2 is decreasing because it's a low pressure. The air at 3 is descending. There you can see the arrows is telling you that. The cloud type at 4 is 4. It's a big base and it's a very vertically a very high cloud. So it's a cumulonimbus cloud. And the type of precipitation associated with cloud 4 is thunderstorms. This is how easy it is to get 7 marks for a question on tropical cyclones. They can also give you an infographic or a source-based question on tropical cyclones. What evidence indicates that the tropical cyclone developed in the southern hemisphere? Give 2 reasons from the infographic that indicate that the tropical cyclone is in its mature stage. How will the descending air at A influence the cloud cover in the eye? 144, give a reason for your answer. Can you see how many times they ask you to give a reason? Give a reason for your answer to question 1.4.3. And then, what is the relationship between the wind speed and the air pressure as indicated in the graph? A, ahead of the eye. You can see, here's the eye. There's a head of the eye. And within the eye. So you basically have to be able to read that graph. Why is area B in the sketch of the isobaric representation referred to as the leading left quadrant or the dangerous semicircle for 2 marks? How does the leading left quadrant or the dangerous semicircle develop in the tropical cyclone? And so we are going to look at the answers. What evidence indicates that the tropical cyclone developed in the southern hemisphere? First of all, here's the arrows telling us it's clockwise rotation of air. The position of the leading left quadrant, there it says leading, so this is the front. Wind direction shown by the symbol of the eye. That eye is an indication that it is clockwise. It is in the southern hemisphere. Boys and girls, remember at any time they can ask you to draw something. Make sure that you can draw some of these symbols. Give 2 reasons from the infographic to indicate that the tropical cyclone is in its mature stage. We have the pressure in the center is significantly below 1000 hectopascal. There you can see there's 974, 972. This one will be 970, 8, 968. So, but very important, it's below 1000 hectopascal. We have a well-developed eye. There it is. The area covered by the tropical cyclone is 450 to 900 kilometers. The leading left quadrant is visible. That part is visible. And then the isobars are closely spaced. You can see it here, you can see there, which shows you that the pressure gradient is very steep. How will the descending air at A influence the cloud cover in the A? There will be no cloud cover or it will be clear skies. Give a reason for your answer. Why will we have no cloud cover? Because the descending air heats up, which results in no condensation. We have adiabatic heating, which reduces moisture. That means the air is dry. What is the relationship between the wind speed and air pressure in the, as indicated in the graph ahead of the eye? There it is. There's the wind speed. How's the wind speed? Low. Air pressure is high. Let's say what I say. Air pressure decrease and this wind speed increase. Sorry, there it goes up and there it goes down. That is the relationship. Within the eye, both the air pressure, there is the eye, and the wind speed decreasing. There it goes down, there it goes down. Both of them decreases. You literally have to read that graph. Okay, the next question. Why is area B on the sketch of the isobaric representation referred to as the leading left quadrant or the dangerous semicircle? Because it experiences the most intense weather conditions. How does the leading left quadrant develop in the tropical cyclone? It developed because of the forward movement of the tropical cyclone, which combines with the rotation of the system. So it's a combination. It's the forward movement plus the rotation of the system is giving rise to the dangerous left quadrant, leading quadrant. We are now going over to subtropical anticyclones and ocean currents, referred to sketches A and B below, and then you choose the multiple choice questions. Sketch A shows typical summer, spring, winter, or autumn conditions. This one. Your answer to this one is winter. Why do I say that? Because this is the Kalahari high pressure system, or the Kalahari anticyclone, which is prominent in winter over South Africa. Same question, number 2. The low pressure system in sketch B forms due to what over the land? Low evaporation, intense heating, cold dense air, or heavy rainfall. There is the low pressure that I'm talking about. Low evaporation means there's not water, it's not hot. Intense heating, a low pressure system, is associated with warm air, because warm air rises. So your answer is B, always. Low pressure is associated with rising air, and we have warm air that's rising. Next question. What is the concept used to describe the elongation of the isobars associated with the South Atlantic anticyclone in sketch B? They talk about that part. Elongated. Is it backing, divergence, reaching, or convergent? Convergent. Answer is reaching, always. A high pressure that makes that elongated shape is reaching. If it is a low pressure that's doing it, we talk about a trough. A trough. It's like a concept that you need to know. The anticyclones in sketch A and B change their position seasonally because of the rotation of the Earth, frictional drag, shifting of the ITZ, and the Coriolis force. So what they say, this is part of the subtropical high pressure belt. It's moving up or down, north or south, and it is happening because of the shifting of the ITCZ around the equator. Okay, the South Indian anticyclone in sketch B is likely to feed more moisture over the east coast in comparison with sketch A because it is a blocking high, it has a larger fetch area, it diverges dry air, or it has a smaller pitch? And the answer is large, because you can see there it picks up a lot of moisture and warm air as it rotates around the high pressure. Next question, the low pressure system in sketch A, it's that one, will move in a what direction? North, west, east, or south? Correct answer is east. It's a coastal low pressure, and it moves, or it originates over there and it moves all along the coastline. Okay, 117, berg winds are most likely to develop in sketch A because of the presence of what and what? The Kalahari anticyclone, a coastal low, South Indian anticyclone, or a heat low. And then you get, this is a complex multiple choice with options. Always remember, with a berg wind, you need the Kalahari high pressure cell and a coastal low so that air can move from high to low over the escarpment. So your two options is that one and that one. So the correct answer will be A, and A is the correct options, or combination is 1 and 2. The inversion layer that forms over the escarpment in sketch B will favor the formation of what and what. Remember, it's summer, so I will have the inversion layer above the escarpment. So frost is out, it will form rainfall and it will form hail. So it is 2 and 4. So your correct answer will be C. We're coming to the inversion layer, which also forms part of the subtropical anticyclone. Refer to the sketch below showing the changes in the position of the inversion layer. Refer to sketch A. Identify the season illustrated in sketch A. Give a reason for your answer. Refer to sketch B. Identify two factors visible in the sketch which influence the climate of South Africa. Explain the role played by descending in the development of the inversion layer. And refer to sketches A and B. In a paragraph of approximately 8 lines, describe how the position of the inversion layer in sketch A and B influences the amount of rainfall in the interior of South Africa. Let's look at the answers. Refer to sketch A. Identify the season illustrated in the sketch. It is summer. Number 2, give a reason for your answer. We have weak descending of air. The inversion layer is above the escarpment. There's the escarpment. So it is above the escarpment. And we have warm moisture air winds will reach the interior. The air rises over the escarpment. We will have moisture onshore winds which will receive the interior, and we have wet conditions over the plateau, over the interior. That's why it is summer. Refer to sketch B. Identify two factors visible in the sketch which influence the climate of South Africa. We have the plateau there. We have the height above sea level. We have ocean currents. We have the inversion layer. We have the descending air, or the Kalahari high pressure. You can even add anticyclonic movement. And we have distance from the ocean. It's 2 marks, so there is lots of options for you. Answers are there. Refer to sketch B. Explain the role played by descending air in development of the inversion layer. the air as the air subsides, it compresses and heats up. Adiabatic heating is there due to subsiding air, any one of these two. Then it's our paragraph question. In a paragraph of approximately 8 lines, describe how the position of the inversion layer in sketches A and B influences the amount of rainfall in the interior for South Africa. Sketch A, the inversion layer is above the level of the escarpment. Moisture air flows into the interior. We have unstable conditions that causes air to rise. Here it comes. Air rises, condensates and cools down and condensate. Clouds form and we have rainfall. You can remember that sentence, ne? Air rises, air cools down and condensates. It forms clouds and I have rainfall in that order. Then sketch B, inversion layer is below the level of the escarpment. This moisture air cannot reach the interior. We have stable conditions, clear skies. There's no condensation that occurs, therefore there's no rainfall, and it's indicating there that it is dry conditions. We are quickly going to look at berg winds and coastal lows that they be also in the topic of subtropical anticyclones. Name the high pressure cell and low pressure cell indicated on the sketch map that leads to development of berg winds. Which sketch A or B represents the formation of berg winds? Give a reason for your answer to question 152. Explain why cloudless conditions are indicated by the station model at X on the sketch map. And in a paragraph of approximately 8 lines, explain how berg winds impact negatively on the natural vegetation and suggest strategies that can be put in place to limit this negative impact. Okay. Name the high pressure cell and low pressure cell as indicated in the sketch. There is the Kalahari high pressure cell and this is a coastal low. Which sketch A or B represents the formation of a berg wind? Its answer is B. Why? This wind is blowing from high to low, from the interior to the ocean. So it's number B. Give a reason for your answer. Air from the interior at the Kalahari high pressure cell descends down the escarpment. There it descends down the escarpment. The air from the Kalahari high pressure moves towards the low pressure. There's a high pressure, there's a low pressure. Air moves from a high pressure to a low pressure. And the air is offshore towards the ocean. It blows off the shore. One fact for 2 marks. Explain why cloudless conditions are indicated by the model at X on the sketch. Because the air is descending, they are dry, it's offshore. This descending air heats up at the dry adiabatic lapse rate, which results in no condensation. If I don't have condensation, I don't have clouds. The descending air heats up and the remaining moisture is evaporated. In a paragraph of approximately 8 lines, explain how berg winds impact negatively on the natural vegetation and suggest strategies that can be put in place to limit the negative impact. You have to explain the negative impact, and you have to have strategy. So you have to have two parts of the answer. The impact, the berg wind dries out the natural vegetation. It increases the temperature of the area and makes it vulnerable to veld fires. And the veld fire can destroy the natural vegetation. Strategies: create fire breaks, ensure water accessibility so that you can kill the fire with water, awareness of the negative impact of veld fires, availability of emergency services. You can block or maintain or monitor with lookout towers and warning systems. Educate the community of the danger of berg winds, and you can develop windbreaks. A line thunderstorm, also part of the subtropical anticyclone topic. According to the extract, in which season do line thunderstorms commonly occur? Describe the temperature and moisture content of the wind A and wind B that leads to the formation of line thunderstorms. Explain why the heaviest rainfall occurs the closest to the moisture front as evident in the source. And explain the negative impact of line thunderstorms. Look here, 6 plus 4 is 10, plus 4 is 14, plus 1 is 15. So it's a source-based question for 15 marks. Let's look at the answers. According to the extract, in which season do line thunderstorms occur? During summer. You can see the answer is there. Describe the temperature and the moisture content of wind A. There's wind A. It comes from the cold Benguela current. So wind A is southeasterly. There it is. It's cold and dry because it's coming, it blows over the cold Benguela current. Wind B comes from the northeast. It blows over the warm Mozambique current, so the air is warm, and it's coming from the ocean, so it is moist. Explain why the heaviest rainfall occurs closest to the moisture front is evident in the source. Close to the moisture front, we have a rapid uplift of air along the moisture front. It have a greater vertical condensation, and we have dense line of cumulonimbus clouds. Or you can say it's further from the moisture front because there's less uplift of air further from the moisture front, a less vertical condensation, and a less cloud formation. Always look at the question. The question said closest. Then you stick to the question, the answer for the question. Okay. Explain the negative impact of line thunderstorms, heavy rain, thunder. Natural habitats will be destroyed. Ecosystems will be destroyed. Biodiversity will be reduced. We will have soil erosion because the topsoil will be washed away. Mass movements can be triggered. Wildlife can be destroyed. Natural vegetation can be uprooted. Trees can be uprooted, or natural vegetation can be destroyed. Water quality will be reduced. You see, they want 3 facts. Increase the leaching of soil. Sinkholes can form, or we can have silting or deposition of material. We are going over now to valley climate. And there's a diagram on a valley climate, and it's a column A, column B. The direction in which the slope faces in relation to insulation is aspect. If you look, see the word direction and slope. it must guide you immediately to aspect. This sketch represents a valley in which hemisphere? It's in the southern hemisphere. How do I know that? This is south, there is north. So what's happening here is, remember, if the sun in the southern hemisphere, the sun is coming from a north angle. So this slope faces north. I have my crops there. This will be the shadow zone. This is the north facing slope. So that's why I'm saying it is in the southern hemisphere. If you get a sketch like this, look for north, and immediately above north, you draw in the sun. You will look there. You draw in the sun. If it's not there, then it must be the other one. The wind occurs due to terrestrial radiation, is katabatic winds. A temperature inversion occurs between A and B due to what? A decrease or increase in temperatures with height. A temperature inversion is always an increase in temperatures with height instead of a decrease. The form of precipitation that would occur at X, it's going to be frost, that those temperatures drop below freezing point. Which fog may form in the valley on calm, clear, calm nights? It's radiation fog. And the northern side of the valley is covered with trees because of less evaporation or low evaporation. Urban climates refer to the graph showing the difference between rural and urban temperatures. Define the concept urban heat island. Give the highest temperature recorded. So this is a concept you need to know. That one you read off. Explain two ways in which the buildings at Z contribute to the high temperatures. And in a paragraph of approximately 8 lines, suggest sustainable building strategies to reduce the urban heat island effect. Answers. Define the concept urban heat island. You start with an urban area of higher temperatures surrounded by rural area of lower temperatures. Give the highest temperature recorded. Then you look here, where's the highest point? Take a ruler and you go and check, and it's there between 34.6 and 34.8 degrees Celsius. Explain two ways in which the buildings at Z contribute to the high temperatures. The high building density traps the heat. The buildings are very close to each other. Tall buildings create large surface area for heating. There's multiple reflections of heat by the buildings, the color and the glass. The dark painted buildings absorbs heat. Building materials results in more heat being absorbed. Taller buildings limit airflow, and air conditionings used in the buildings cause more heat on the outside. In a paragraph of approximately 8 lines, suggest sustainable strategies to reduce the urban heat island effect. Paint your buildings with light colors. Have rooftop gardens. Replace tar and concrete with cobblestones. Minimize large glass windows or structures. Using green energy in buildings, solar. Use low energy light bulbs. Decrease building density. Make sure that the buildings are not built close to each other. Improve insulation in the buildings. Use eco-friendly or natural building material. Restrict the height of buildings. Use mirrored glass, which is more reflective, and plant areas for parks or planting trees or water features. Make sure that there's more water features or green areas. Then we go over to a pollution dome, and the questions here is what represents a pollution dome? You must choose between A and B. Which pollutants are, which diagram have pollutants that are dispersed, and which one of the two shows a denser concentration of pollutants over a polluted area? So the answers, a pollution dome at night is B, is lower, is more concentrated. There's no activities, it's cool air. So the cool air forces the air to sinks. Pollutants are dispersed. It's A. You can see there's lots of space. So all your polluted material, your pollution is spread over a large area. Denser concentration of polluted air over the urban area will be B. If that one is dispersed, then this one will have a denser concentration. Synoptic weather map. They can give you a synoptic weather map, ask you questions on that. Name the low pressure cell A. Why is pressure cell A known as a traveling disturbance? Why is there a greater possibility of precipitation at B than at C? Give evidence that this synoptic weather map represents typical summer conditions. Which anticyclone, D or E, has a greater subsistence of air? And then use the pressure reading on the synoptic weather map to support your answer to question 1.4.5a. And then we're going to look at the answers. Name the low pressure cell at A. There it is. It's a low pressure. It's on the coast, so it's coastal low. Why is it known as a traveling disturbance? Because it is a moving system. I just want to show you, he starts here on the west coast and he moves all along the coastline. Why is there a greater possibility of precipitation at B than at C? Because of the clockwise rotation of air. Air moves there from sea to the land. Moisture is carried over the land at B. We have onshore winds at B. At C, I have dry air because air moves from the land to the sea. So I have offshore winds. 1.4.4. Give evidence that the synoptic weather map represents typical summer conditions. There you can see the date. Or the high pressure cells are in a southerly direction. Here they are more south of the country. And the cold fronts or the mid-latitude cyclone is further south. Or you can say a tropical depression there is evident. You can see there the pressure there is at 1,000 hectopascal. 145. Which anticyclone, D or E, has a greater subsistence of air? Answer is E. Use the pressure reading on the synoptic weather map to support your answer. At E, the pressure reading is 1032, and at D it is 12024. D has a lower pressure reading than E. Or you can make that your other answer. Okay, boys and girls, then Miss Zondi will continue with this lesson, and she's going to go on with geomorphology, and she will start with drainage basins. I'm going to give over to her now.
Good day, grade 12. My name is Cynthia Zondi. I am going to continue with today's revision lesson. We are going to look at the geomorphology section, and the first subsection of the work, we're going to look at the drainage basins. So with this section of work, we're going to look at the concepts, processes that takes place within a drainage basin. And we're also going to look at the different types of rivers. So you've got a multiple choice type of a question here where you have to choose the correct answer from letter A to D. All right, the first question is, this type of a river only flows after heavy rainfall. So the keyword there is after a heavy rainfall. And then your options are the perennial river, option B, periodic river, C, exotic river, and the last option there is episodic river, which is the correct answer there. Okay, from the statement, what is important, it only flows after a period of, an episode of heavy rainfall. So that's episodic river. Right, and then we move on to the next question. These rivers are found mostly in the eastern half of South Africa. So what is key in this multiple choice is that mostly found in the eastern half of South Africa. So which rivers are those? Are the options still on the types of rivers that we have studied throughout the year? It's a perennial river, A, B, periodic river, C, exotic river, and D, it's episodic river. So as I've indicated, on the statement, it says mostly in the eastern half of South Africa. And then these rivers, remember your correct answer there, it would be a perennial river. And the eastern half of the country, this is where we experience high rainfall percentages. And we also, it is in the humid region, and which therefore informs why these rivers are perennial. They flow throughout the year, regardless of whether is it a rainy season or not. So that section of the country is the eastern, mostly the eastern half of the country. So the correct answer there is perennial river. Right, 2 and 3. These rivers originate in a high rainfall region and flow through a dry region. So from here, the keyword is originate where? On the high, in a high rainfall region, and they flow through to a dry region. So we've already indicated that we've got the eastern half of the country that is having high rainfall areas. So such rivers that we are looking at, it would mean that they would be flowing from the east of the country and to the dry region. So which river is this one? Is it perennial, perennial, periodic, exotic, or episodic? So the correct answer there is exotic river. So you would think of, maybe, for example, your Orange River, which flows from the Lesotho and the Drakensberg region, which is your high rainfall region of the country. And then Orange River, it flows through towards the west of the country and towards the coast, towards the border of South Africa and Namibia there. So that is the exotic river. These rivers only cut through the water table in the wet season. So it cuts through the water table in a wet season. So it means that for this type of a river to flow, its water table, the base flow of that particular river, it goes above the water table in which season? During a wet season. So then from the four options, the correct answer there is a periodic river. So it is only when during a wet season where now the water table it cuts through the water table would be rising above that section, and then we would have that river being able to flow there during a wet season. All right, still looking at the multiple choice of this area of types of rivers and the processes there. The 215, it says, look at X, which illustrate this type of a flow. So we've got our diagram that is showing us where X is there. And then with the options of answers, is X showing a laminar flow? Is it showing a base flow? Is it showing a turbulent flow? Is it showing a turbulent flow? And then the last option, is it a sheet flow? So which of the four options is the correct one there? We would know the characteristics of the laminar flow. The water is flowing smoothly there, and then base flow, it's underground flow. And then also we're looking at the sheet flow, which would be the water that is flowing in sheets over the surface. So the options would either leave us with the two types of flow that we relate, that it would either be a laminar flow or a turbulent flow. But when you look at the diagram itself here, it shows that water is spiraling, and that it can't be sheet flow where we say water flows in sheets. And then base flow, I said it's water that would be flowing from the underground. And also with the laminar flow, we know that the laminar flow, it's water that is flowing smoothly there. So the correct answer there would be a turbulent flow. And what makes this the correct answer? We look at what is also indicated on the diagram there, that says due to the uneven riverbed, then there is turbulence. So water is it's flowing on an uneven surface there. The ability of a rock to allow water to pass through. So from the four options, the correct answer is permeability, because when you look at, okay, this we would rule it out, and this one we would also rule it out. So when you look at the statement, the ability of a water to allow water to pass through. So that is your key part of that statement there. So the correct answer we're saying is permeable, and then we don't take porosity, because with porosity we're looking at the rock that has got pores, and it just holds water in those within the pores that it has. So water there is not passing through, but it's kept within the pores there. Then two factors that will result in a higher infiltration. So we're looking at what is it that would result in higher infiltration. From these options, is it when we're experiencing drizzle, or when there's thunderstorm, or when the slope is having a steeper gradient, or when we have a gentle gradient? So from these options, you must be able to also eliminate the wrong answers there. And then what comes out to be the most correct answer is that if we are experiencing drizzles, water that is, rain that is flowing, that is slower, and then water, then it's allowed to seep through because of the soft rain. And then also the other thing that also allows for infiltration is that the slope there, it is gentle. So the correct answer is option 1 and 4. A higher rate of infiltration will result in, so if we have higher rate of infiltration, so there's more of water that passes through the surface there, are we going to have lower stream order? Yes, is it going to result in lower stream order, or is it going to result in lower drainage density, lower water table, and lower soil moisture content? So higher infiltration results in what? It results in a lower stream order because more of the water is passed through onto the underground, so there will be less stream. So then we'll have lower stream order there. And then also because of more water that passes through onto the underground surface, then we will also have less streams that we can calculate to give us the drainage density. So then we will have a lower drainage density. Refer to the drainage patterns. So we are now looking at what? The drainage patterns. So we've got two drainage patterns that are illustrated as A and B. And then the first question says, identify the drainage patterns in sketches A and B. So the next question, remember we said you'd rather, when you are playing the video, you would pause the video so that you can attempt the questions before you move on to the answers. State the underlying rock strata and the rock type on which the drainage pattern A is developed. So you have to give two answers there. The underlying rock strata and the rock type on which this drainage pattern is developed. And then explain how the underlying rock structure influenced the drainage pattern in A. The drainage density in B, is it high or low? Determine the stream order at X. Explain the relationship between the stream order and the drainage density. So when you get such questions, you must underline. So this question, it requires you to explain the relationship. What are you going to mention in your answer? You're going to mention the stream order, how it influences the drainage density. Explain how the slope or the gradient and permeability of the underlying rock influences the drainage density in B. So it's a 4 marks question that you have to give two answers to. Right, so these are the answers. Identify the drainage patterns in sketches A and B. So sketch A and B, thus is your rectangular drainage pattern, and then this is your dendritic drainage pattern. State the underlying rock strata and the rock type on which the drainage pattern A is developed. Okay, the underlying rock strata is the rock that has got joints. It's a jointed rock. And you can also mention that it is a horizontally layered rock. And then what rock type are we talking about? We're talking about the igneous rocks, or you can also mention the sedimentary rock. So this drainage pattern, it's formed on rocks that are jointed. As you can see that we've got the faults or the cracks that may have resulted in the water only flowing in those cracks or the jointed rock. And then the type of a rock, it is an igneous rock which has got homogeneous resistance. So the resistance is the same right throughout here. Then also the type of a rock, it can be a jointed rock that has got what? The hard and the soft part. So this is where we see the sedimentary rock also being an example, because where these streams are flowing, it means the type of a rock that is allowing the streams to form there, it is on the softer part of the rock. Explain how the underlying rock strata influenced the drainage pattern in A. So now we are explaining how this underlying rock strata influence this pattern. We're saying that rivers are flowing in joints that have got 90-degree bends. So because of the rock that has got the faults and the joints, so then the flow is forming 90-degree bends. And then also tributaries join the mainstream at 90 degrees. So as you can see, the tributaries that are joining the mainstream that we can identify here, the angle at which they are joining, it is at 90 degree. Right, furthermore, the drainage density in B, is it high or low? So now we are looking at this drainage pattern. The correct answer there is high. Determine the stream order at X. The stream order is 4. So we know how to calculate it. It would be a 1 here and a 1 here, a 1 there and a 1 there. So a 1 plus 1 would give us this 2. Then there's a 2 here as well. So this 2 will result in a third the stream order. A 2 plus a 2 gives us a 3. 3 stream order. And then when we look at what we have here, we've got a 1 and a 1 there. So we've got a 2 here, a 1 and a 1 there. These are 1. So the sources of the streams there are your stream order 1. So we've got a 2 here again. So there's a 2 and a 2 here, then that changes the stream order to be a 3 there. So now we've got a 3 plus another 3. So that gives us the 4th stream order, because where X is, you see there's this 3 that is there, it's coming and it's flowing there, and then there's this 3 that is also coming in to join there. So this is where X is showing stream order 4. Explain the relationship between stream order and the drainage density in B. The higher the stream order, the higher the drainage density. So you can see that there's lots of stream order 1 that would mean that the drainage density there is higher. So there is more of the streams that result in the higher stream order there. And then explain how the slope or the gradient and permeability of the underlying rock influences the drainage density in B. The steeper the slope promotes runoff. So there's if the slope is steeper, it cuts more river channels. So there's more of river channels that we can identify there. And then rocks with low permeability, so rocks that are having high resistance, they promote more runoff. So if the rock is more resistant, more of water would be flowing on the surface, and therefore there will be less infiltration there. Right, we are now moving on to river profiles. So we're looking at river profiles. The question that we have just picked as a prep for your exam, we're just looking at to the longitudinal profile X and Y below. So there's profile X and there's profile Y there. What is a longitudinal profile? It's a concept. You have to be able to explain what a longitudinal profile is there. A is known as temporary or permanent base level of erosion. So there's A that we can identify there. Is it a temporary or permanent base level of erosion? And then give an example of the natural temporary base level of erosion that could develop at a nick point. So we are looking at this point, which is a nick point there. So what natural temporary base level can develop there? And then which profile, X or Y, is graded? So looking at these two profiles, you can see there's the river, it flows and then it comes across a nick point and then it continues to flow. But when you look at profile Y, the river is just flowing smoothly there in a smooth concave shape then. So which of the two is graded? Right, let's look at the answers to that. What is a longitudinal profile? It is the side view of a river from the source to the mouth. So when we look at this diagram, it's showing us the river from the source to the mouth, which is towards the sea there. All these are showing the source from the where the river starts to the mouth, which is towards the sea. And then A, is it known as a permanent or temporary base level? A, it's permanent because this is where there is the lowest level of erosion when the water gets into the sea. So there is the lowest level of erosion. So it's a permanent base level of erosion. Give an example of a natural temporary base level of erosion that could develop at a nick point. So in the upper course where we have these nick points, so the natural base level that can be identified here would be example A, waterfall, right? Then which profile, X or Y, is graded? So looking at both the profiles, which one is graded? Graded meaning it has a smooth profile and both the deposition and erosion are at an equilibrium, which is the follow-up questions that we are going to look at there. So which one is graded? It's profile Y rather, with that smooth concave shape that you can identify there. Okay, then furthermore, these are the questions that were also linked to the profile X and Y. Give a reason. Why are we saying that profile Y it's graded? This would be the correct answer. It has a smooth or a concave shape. Smooth concave shape, but your answer would still be correct if this is left out. And then all temporary base levels are removed. So when you look at this profile, we don't have any of the base levels of erosion because, the temporary base levels, the level of erosion, when erosion was taking place, also deposition was taking place at the same level. So it smoothened this profile or the river. Rate of erosion and deposition are at an equilibrium. Then these other questions explain how the profile answer to question 2.3.4 developed. So how did the graded profile develop? The vertical erosion, it eroded the nick point. So initially there was this nick point and it got eroded, and then as it got eroded, it was due to headward erosion. So erosion was taking place in that direction. So there was a headward erosion, which removed the nick point. And then also there was lateral erosion that widened the river. So it wasn't only headward erosion, we had also lateral erosion that made the river to be wider. And then all the debris, when this nick point was eroded, what happened? They were deposited in the lower course, okay? And then a state of equilibrium was reached between erosion and deposition. So there was a balance of act here between erosion and deposition, which resulted in this profile. Okay, we still have another question on the river profile. It says, draw a rough cross profile of the river valley B. So we are looking at a cross profile of this part of the river there, the river valley at B. So this is how your cross section or the cross profile should look like. So it will show us those deep, narrow valleys that we can identify there that are showing us a sharp V, and that is then from this we want to know why do we have this shape. Give a reason for the shape above or the shape that you have drawn there. This is because of the vertical and downward erosion. And then also it is in the upper course of the river. So the valley at B here, it's in the upper course of the river. And then the processes that were responsible for this sharp, narrow V valley, it's a downward and vertical erosion. Okay, now we are looking at this other landforms and the processes that are taking place there. So refer to the sketch below of fluvial landform or feature. The fluvial landform or feature illustrated in the sketch, is it a braided stream or is it a meander? So you look at the sketch that is illustrated here. Do you see a braided stream or do you see a meander? And then give the characteristics of the river in the lower course in which this fluvial landform or feature that you have answered in question 2.4.1 developed. Explain how the gradient influenced the development of the fluvial landform or feature illustrated in the sketch. For 4 marks there, you must give 2 facts to respond to that question. And then these are your other questions that can be asked from this. Refer to the cross section. So we can see there's the cross section, X and Y there. Then the questions are identify the slopes A and B on this landform feature. And then the other question, which cross section, X or Y, represents the line drawn between A and B? So there's the line that is drawn between A and B. So which of the 2 cross sections represents this part of the river there? The next question, explain the processes involved in the formation of slope A. So there is slope A. We want to know what processes resulted in what is illustrated there. And also at B, let's look at the answers, the possible answers for all the questions. The landform or the fluvial landform or feature illustrated in the sketch is a meander. So we can see that the river is it's moving from side to side. So it is a meander. And then give the characteristics of the river in the lower course in which the fluvial landform feature, which is a meander, developed. So if we look at the characteristics of the river way in the lower course, the river would have a gradual or a gentle slope, and then it would be flowing slow. There's evidence of flooding taking place, and also there's deposition. And the type of a flow there, it is laminar rather, and then it's also meandering. So those are the characteristics there of a river in the lower course. All right, furthermore, give a characteristics of the river in the lower course in which, okay, it's still some of the characteristics. We'd have oxbow lakes forming, we've got levees that would develop there, the distributaries, the braided stream are also formed at the lower course. It's also have the river mouth. The erosion process that is dominant there, it's lateral erosion. And the river also, it's more wider. And we have shallow river channels there. So all those are the characteristics of the meander in the lower course. Explain how gradient influenced the development of the fluvial landform of which are illustrated in the sketch. So we are explaining how gradient resulted in the development of this. The gradient is gentle, therefore it caused the river to flow. Remember when we say explain how, you must give the factor and the qualifier. So we are saying the factor is that the slope is gentle. Therefore, it influenced the river to flow slower. And then here, the river started to bend. So we've got bends, and also that resulted in lateral erosion taking place. The other thing, there's erosion on the outer bank, and therefore that resulted in deposition on the inner bank. So those are the how gradient have influenced the development of this landform. Okay, identify the slopes A and B. We say this is the slope A and this is slope B. So you look at the arrow pointing there. So at A, we've got a slip off, and then at B, we've got the undercut slope. And familiarize to these identify the names that we use to identify there. Which cross section, X or Y, represents the line between A and B? So we said we are looking at this part of the meander. So when you look at this cross section, is it X or is it Y? So with the processes that are taking place, we've got erosion that is taking place this side. So that's how we've got more erosion taking place on this side, and we've got deposition. So the correct answer there would be profile Y there. Then we've got another set of questions that are also linked to this. Explain the processes involved in the formation of slope A and B. So at slope A, which is where we are on the diagram there, what has happened is that the river is flowing slower. So it is your inner bend there. So the river is flowing slower. And then there's more deposition that is taking place, and that results in a slip-off slope developing there. And then at B, this is where we are. So your B, it's the outer bend of the meander. The river there, it's flowing faster, and then we've got more of erosion and undercutting taking place there. And then there is continuous undercutting that takes place. So you can even see the elevation of the surface between these two lines that shows that this would be a higher ground and this would be the lower part of the river banks there. And then it causes the bank to collapse, forming a river cliff or an undercut. So all these would explain the processes that takes place at A and B. Okay, still on river processes, we're looking at now river rejuvenation. What is river rejuvenation? It's a concept, 2 marks. State 2 possible causes of river rejuvenation, and then also draw a labeled freehand cross-section from A to B of the illustrated river rejuvenation, and then marks will be allocated for the correct shape of the rejuvenated valley, and then also for indicating the new flat plain. So when you are given such a question, you must take note of where the allocation of marks are. And then indication of the terraces, that is what you need to indicate on that cross section. Right, for your answers, we are looking at how did the river terrace develop? It's another set of questions that also is linked to this. And then also explain how the illustrated landscape will negatively impact on the infrastructure development. And then let's look at the answers to these questions. What is a river rejuvenation? It is a process where a river regains energy and begins to erode vertically or downwards again. State 2 possible causes of river rejuvenation. The causes are the change in the gradient, there is an increase in the volume of water, and then also joining of the faster tributary. So what results in a river gaining more energy is because of the change in the gradient. It was flowing on a higher and then moving on to a more gradual, so that can also influence the flow of the river. And then also if there is an increase due to higher rainfall or maybe tributaries that are joining that stream, it regains energy. So that makes the river to be energized or rejuvenated. With the questions that are still on river rejuvenations, draw a labeled freehand cross-section from A to B. So on the diagram, this is from A to B. We're looking at the entire river from riverbank to another. So your marks will be allocated for the shape of a rejuvenated valley and indicating the new floodplains as well as indicating the terraces. So when you are at A, between A and B, what we see is we've got this initial floodplain, and then it changed into this, and then it changed into that. So all this from the diagram, you must be able to see it before you can even draw it. So when you look at it on the cross section, it must look exactly like this from the plan view of this diagram. So this is how then, when there is rejuvenation, there will be new valleys that are going to be formed there, and then there will be new floodplains. And when you look at the landscape, it's showing the terraces or the kind of like steps. So from the plan view of the diagram, you should be able to then depict how it looks like in a form of a cross section like that. Okay, we still have some few questions on this one. How did the river terrace or illustrated sketched form? A rejuvenated river cuts into the valley floor. So if the river gets rejuvenated, initially it was flowing in this valley and then it cut into deeper valleys like that. So all these are new valleys that are formed as the river cuts into downward landscape. So due to downcutting, it creates new floodplains. And then also a step forms between the old and the new. So we've got new floodplains. So these would be the new floodplains. And also here we've got a new floodplain if we look at the exact part of it. So there's new floodplains that are formed. They explain how the illustrated landscape will negatively impact on infrastructure development. So these are your answers. The steepness of the slope will hamper construction. So it will make it difficult for construction to take place of such as roads and railway lines. The softness of the underlying rock, it causes instability. So the rocks would either have some sinkholes, and that is the impact of the negative impact of such if you are to develop infrastructure. Terraces make it costly to build bridges. So those are the impacts of such a landscape. Wide floodplain makes it difficult to build bridges. All right, the last section quickly that we have, it's river capture. So with river capture, these are the questions that we have. Which river, A or B, has more erosive power? Give one reason evident on the sketch to support your answer. Identify features C and D. Give one characteristic of feature D. And then in a paragraph of approximately 8 lines, describe the changes that the river E will experience after river capture has taken place. So you've got your before the river capture and after. So those are the diagrams that you have there. So let's look at the answer. Which river, A or B, has got more erosive power? We've got River A and River B. Which of the two has got more erosive power? Looking at the diagrams, before you can come up with the answer, study both the diagrams so that you can be able to determine which one will cut through the watershed there. So that is River A. Give one reason evident in the sketch to support that answer. It is flowing at the lower level. So on the diagram, it is showing there. There's your 220 meters. So when you compare the height above sea level there, this river is flowing on a lower level. And then it has captured River B. So when we move here now, we can see it has cut through the watershed, and then also a steeper gradient to watershed. So the watershed is on a steeper gradient, which is between 220 and 880. There's more volume of water in River A. So the capturing that has taken place resulted in more water now flowing in that stream that has the captor. And furthermore, these are some of the answers that we looked at into. Identify features C and D. So this is where we are, feature C and D. What is C? A C, it's a wind, D rather, it's a wind gap. And then your C is an elbow of capture. So the shape or the point where the capturing takes place here is giving us that elbow shape, which is the elbow of capture. And make sure that you give the answer in full. Give one characteristic of feature D, which is your feature D. We said it's a wind gap. What characteristics do we have? It is a dry area. So at this point, there's no water. It is a dry area. And then also it has river gravels. So there's a sandy rock kind of there. And then it is located below the elbow of capture, as we can see there. And then it is located above the misfit. A misfit is this stream that a discontinued, the stream that is left out, stranded after the capturing taking place there. And then the other question that was also asked on this, write a paragraph of approximately 8 lines where you describe the changes that River E will experience after river capture. So we are looking at this misfit. So the volume of water is going to decrease. The river's velocity or the speed is going to decrease. The river has less energy because there's less water, and it becomes less erosive. The river will experience more deposition. The length of the river is shortened. The stream order will also decrease, and the river will become non-perennial. And we can also accept periodic because the conditions of this to exist, it's also at some point there's no sufficient water. The width of the river is reduced, and the size of the drainage basin is also decreased. So that's how your paragraph should be structured. Right, boys and girls, we have that 30 marks that we said you should also prepare yourself on. However, what we are giving you here is the QR code, which you can scan and open, and then you will be able to find some relative information that you can use for your revision for tomorrow's paper. And then these are your exam techniques. You have to be in the venue at 8. Make sure that you've got all your stationery, and you can also ask from your teacher. Use your 10 minutes reading time effectively, and then follow instructions clearly and read all questions thoroughly. You've got enough time, which is 3 hours, so you need not rush your exam. And then answer every single question. Don't leave out the blank spaces. And then use your time effectively, managing every question of 60 marks accordingly, giving 45 minutes to your question 3, your question 1 and 2, 60 minutes, which is an hour. Then your 15 marks, 15 minutes rather, you use it to just go around and see which questions maybe you didn't answer. And then before you start, try to relax yourself, and we believe in you. Study while others are sleeping, work while others are loafing, prepare while others are playing, and dream while others are wishing. we have come to the end of our broadcast, and good luck for tomorrow's paper. Thank you.